So the ultimate goal here is to work on solving quadratic equations with the quadratic formula, but kind of a little review, something you might see in section 10.1 is solving this by completing the square. I'm not going to ask that you solve it by completing the square in the test, but this is what you would do. Since the left-hand side is not a perfect square, that is, you can't square this, or this is not the result of squaring a binomial, I'll move the 15 to the other side. Now, we did practice this in section 10.1. What number would complete the square here? We'll take a look at the negative 8. 16, right? Half of negative 8 is negative 4. Square root of 16. So I'll add 16 here, and I'll add 16 here. You add 16 to both sides. Now, the nice thing is that on the left-hand side, this is now a perfect square. So we could write that as something squared. The right-hand side is a 1. Does anyone know what I square to get that left-hand side? Thank you. X minus 4. So x minus 4 squared equals 1. Perfect. Well, this is something for which I can use the square root property now, right? So square root of x minus 4 squared equals plus or minus the square root of 1. All right, well, that's x minus 4 equals plus or minus 1. If I take the time to look at both cases, 1 and negative 1, I'll get my two solutions. I either get x equals 5 or x equals 3. Yay. So that's solving it by completing the square. You could also solve it by the quadratic formula. So, I don't know. Does one of those look much better than the other? Neither of them's that good. But keep in mind something really important. On the exam, I'm not going to make you solve it any particular way. You're going to solve it whatever you find most convenient. And if you gave this problem to me, x squared minus 8x plus 15, here's what I'd find convenient. I'd find it convenient to factor. X minus 3, x minus 5, and well, I think you should be able to read off the solutions right there. So, factoring, completing the square, and the quadratic formula. Just call it QF. All right. You have all three of them to choose from. But certainly, if you're given the choice, you want to do what's easiest. The nice thing about the quadratic formula is that it always works. Always. But it's kind of tedious. The nice thing about factoring is that it's quick, right? The bad thing about factoring is that you can't always factor. You're going to run into problems that just won't factor, so you're going to need the quadratic formula. So that's where we're going. We're going to practice some more with the quadratic formula until we get really good and competent at it. So let's try another one. By the way, the rule of thumb is that when we're live, you're supposed to make me look good, so laugh at all my jokes and interact with me and pretend you're a lively class, okay? Thank you.
You just recorded that, right?
Yeah, I did. I did. So, now it's not a bad idea to look at these and see if they'll factor. These are the tough ones though, right? Where you have to do this times this and find out what multiplies to 10 and adds to 3. I was never very good at factoring these things. In fact, I was actually pretty terrible at factoring them. So, my kind of compromise is I'll look at it for a little bit. If I can figure out how it factors, great. If not, I know the quadratic formula is going to work. So, in this case, let me give you a little bit of help. The quadratic formula is the way to go because this will not factor. So, A in this case is 2. B is 3. And what's C? Good. C is 5. C is 5. So let's see if we can't fill in the quadratic formula and then simplify things. So x is a negative of something plus or minus that squared minus 4 times something else over 2 times something. So I'll kind of keep these color coordinated. B is 3, so it's the negative of 3 plus or minus the square root of b squared, so it's going to be 3 squared, minus 4 times a, which is this one, and I'll need the 2 down there as well, times c, which was 5. Now this is going to simplify a considerable bit, and you do have to simplify it a fair ways in order to get to an answer that's going to satisfy Newton. There's something that often happens with these types of problems, and I'll exhibit it here. There's some wishful thinking. What wishful thinking have I exhibited here? In simplifying what's underneath the square root. Yeah, I dropped the negative. I'm not sure why, but it's just an easy thing to do. But you can't ignore that negative because we have to work with it. You're not going to be able to just leave a negative underneath the radical. The first thing you should do when you have a negative underneath that radical is get rid of it, split it off. So it's going to be the square root of 31 times the square root of negative 1 divided by 4. So I wanted to get rid of that because I can simplify this now. How does the square root of negative 1 simplify? I. So negative 3 plus or minus the square root of 31i over 4. Now you got to be careful not to accidentally be a little sloppy and write the I underneath the radical. We will not take the square root of I in this class. My guess is that Newton is going to want negative 3/4 plus or minus the square root of 31 over 4 times I. Something like that. One thing that I suggest students do sometimes is write the I in front of the radical. So negative 3 plus or minus I times the square root of 31 over 4. That way it's clear that the I is not under the radical. But if you want to just draw it carefully, that's fine. Either one of these answers here is fine. That one too. How are we looking with this one? Okay? Decent there? Anything that I might have gone over too fast here? You want a little review on that before we move on to the next one? No? Looking good? All right. Got a thumbs up. So I got to tell my viewing audience that I got thumbs up from like everybody. Thank you. All right, Jordan? The formula has the positive and negative case built in. So you're always going to have the plus or minus there. Oh, you're going to have to do that kind of stuff when you have terms that can simplify. So, like here, when I move the 4 to the other side, 4 and the 1 are like terms, I can be able to simplify those. So if that's the case, then yeah, you're going to have to do that. Same thing up here. The 2 and the 8, those are like terms. So if I can combine those either by addition or subtraction, that's fine. So that's why I went a little bit further and simplified that. So it's a good question. Hopefully you're comfortable with the answer. Yep. (4x squared plus 4x plus 17 equals 0. Again, another one of those ugly quadratic equations that probably is not going to factor. You could look for it. 4 times 17 is 68, but two numbers that multiply to 68 and add to 4, I don't think so. Don't spend too much time looking for that because you can use a quadratic formula to solve here. A, B, and C. We're going to plug that into this over here. Negative of something plus or minus the square root of another something squared. 4 times A times C all over 2 times A. So got a 4 here, and then a 4 here. Need one more. Let's do this. Let's do 17 here. So the negative of b plus or minus the square root of b squared minus 4 times a, which is here, times c, which was 17. And the stuff that you have underneath the radical should actually work out pretty good, in as much as it's going to be a perfect square, so you'll be able to take its square root. And in case you don't remember, that's my electronic pause button. So I know it's really high tech, but it's what we're going to have to work with. See if you can't simplify this a little bit. It does simplify pretty nicely. Yeah, there are. by 4, this by 4, this by 4, this by 4. 16 divided by 4 should be a 4.
So the square root of 2.
Why can't I divide by 8?
You divide by 8, but you need to be careful how you do that. You have to split both of them up. So you divide this by 8 and this by 8. This by 8 is going to give you a 2. This by 8 is going to give you 1/2. So you have to be careful where you write it.
Okay.
Which is why I thought I could
That would
combine
confuse me.
terms, but they weren't like because I'm confused.
Okay. I break it up as a square root of
Or you could just write
6.
plus or minus 6.
To get rid of the negative number.
You could do that.
Another bonus, so square root of 256.
But yeah, that, those are your two answers.
Now, you wrote the square root of 16.
Because these are not
That's
6,
square root.
these are I.
But you're done with the square root.
No.
That's just 16.
And I left off by 9.
Now we're going to break that up. Plus or minus 16i. Simplify both of those. Can't cancel. Somehow this became. Alright, we're going to split that up and do a little bit more. But this is good. It's good as far as it goes.
Yeah.
Okay, so let's take a look at this one. That's going to be negative 4 plus or minus the square root of 16. Let's see, 16 times 70 is what, 272? Thank you. Over 8, which is negative 4 plus or minus the square root of negative 256 over 8. Now it's up to you. Some of you might just say, oh, okay, that's 16i. Others of you might be more comfortable splitting that up, splitting out that negative square root of 256 times the square root of negative 1. And that's fine. So you're going to get 16 times I over 8. If I was grading this, you would get 2 points for getting here, another 2 points for getting here, but there's going to be 6 points available on a problem like this, and I want you to get all 6 points. So a couple easy ways to proceed. One way would be like this. Let's just take and divide each term in the numerator by the 8 in the denominator. So negative 4 over 8 plus or minus 16i over 8. Whereas before, I can't cancel the 4 into the 8 or the 8 into the 16. I can't do those individually. What I can do is split it up. And now I can cancel because I'm not canceling into a binomial anymore. These terms are joined. I can't cancel into that. But over here, this simplifies as negative 1/2 plus or minus what? 2i. And that's going to be your last 2 points on a problem like this. It's getting there. All right. How are we looking on this example? Okay. All right. Thank you. Let's see. I kind of have to kind of make one up. Thank you. So, all right, here you go. Try this one. Y squared minus 4y plus 13 equals 0. That one actually should work out pretty nice overall. It's actually going to be a little bit easier than the last one.
I'm dead serious.
No, I know how to do like the whole like figure like where everything goes. I keep forgetting the I and like actually like when I get to the end like actually solve the problem. That's it. So I know the formula and everything.
And basically, as soon as you get to that step, just take care of it.
You're right.
Right, but then that negative will turn into a positive.
Oh, this is how I was like,
Is it working out nice and even for you guys?
okay.
Relatively speaking. So the negative of -4. Be careful that you don't miss that double negative sign. That's why we're writing these parentheses here to begin with. Plus or minus the square root of -4 squared minus 4 times a, which was 1, times c, which was 13, divided by 2 times 1. So that turns into 4 plus or minus the square root of 16 minus 52 over 2, which is 4 plus or minus the square root of -36 over 2, which is 4 plus or minus what? 6i. Good. And we're kind of skipping a step there. That's all right. Now it's up to you, but I think an easy way to finish this up would be something like this. Divide both these by 2. We end up with 2 plus or minus 3i. How many people got 2 plus or minus 3i? All right, well done. Well done. That's what I would expect on something like this.
So if we get a problem that works out like this in Newton, are they going to want it where it's 4/2?
No, they're going to want this.
They're going to
They're going to want this all the way.
All right.
Yeah.
So
Yep.
that's like a limbo to help you out once you get to that second to last step.
If it reduces, then yeah, they're going to want that reduced. Yes. Now you can reduce this in a couple different ways, and I'll show you that in the next problem. So there's a couple more we got to do here. Let's take a look at 2d times 2d minus 5 plus 1 equals 0. Can I just jump in right away and use the quadratic formula?
Now you gotta factor.
No. What do we have to do first?
Factor the 2D.
Distribute. Yeah. Thank you. So distribute, that's going to give me 4d squared minus 10d plus 1 equals 0. Again, look to see if these things factor. This one doesn't. Okay. So then what? Quadratic formula is probably your best bet. I don't think you want to complete the square on something like this. So let's see. We'll do 4 here. That should be 4. Apply a little Photoshop there. Let's try it again. 4, -10. Where is it? -10 and 1. There we go. So 4, -10, and 1. Let's drop that into our quadratic formula. Let's see, we'll start out with the -10 here. -10 there. And then a 4 here and a 4 here. And last but not least, a 1. These simplify. What happens with the double negative? It becomes positive, plus or minus the square root of 100 minus 16 over 8, which is 10 plus or minus the square root of 84 over 8. So right here, you're at about 2 points out of 6. Where do you suppose the next 2 points are going to come from? Yep, split out the radical. So that's going to be 10, and I'll help you out on this one. It's plus or minus square root of 4 times the square root of 21 over 8. So it's 10 plus or minus 2 square roots of 21 over 8. Now we're at 4 points out of 6. So better, 2/3 instead of 1/3. But I want to get that last little bit. Split it apart. 10 over 8 plus 2 square roots of 21 over 8. And then both of these simplify. And it's this simplified form that you're going to want to get to for full credit. So, oops. 10 over 8 is going to simplify down to 5/4. And then the 2 is going to cancel. Square root of 21 over 4. And that's fine like that. How's that look? Okay here? So, as far as stops along the way are concerned, there's 2 points, that's the 4 point, and that's all 6. So try and get up to the 6. There's one last thing that I want to show you, and then we'll do kind of a little mishmash of some problems. Sometimes when you're working in these problems in Newton, they're going to be harder than what we've done here so far. At least initially, they're going to look harder. You're going to get stuff like this. One half n squared plus 3/4 n equals negative 1/12. Even for me, the thought of putting in these numbers into the quadratic formula makes me ill. I'm like, ah. All right, I'm just not really into that part. So what could I do to make this easier for myself? Perfect. If I multiply everything by the LCD, then I'll get rid of all these fractions. So Haley, what would be the LCD for a problem like this, please? 12, yes. So if I multiply everything through by 12, that's going to be this times 12. Plus this one times 12 equals this one times 12. So let's get in that 12 here. 12, 12, and 12. Everything gets multiplied by 12. If it helps you, think of it as 12 over 1, because you can do some cancellation. What's going to cancel in this? 2 goes into 2 once, and in 12, 6 times. So here we're left with 6n squared. How about the middle one? 4 goes into 4 once, and in 12, 3 times. 3 times 3 is 9. Equals what? Thank you. Negative 1. Can I put 6, 9, and negative 1 into the quadratic formula? No. Good job. You need to move this to the other side as 6n squared plus 9n plus 1 equals 0. And that's where you can finish solving this. So, now my goal is not to solve this one. My goal is to show you what to do with these coefficients if you have fractions as a coefficient. So, can I skip to solving it? I don't think it's going to be anything really great. I think you end up with negative square root of 57. Yeah. Yeah. So it's nothing that big. Instead, let me just end with this kind of a note. On your exam, you're going to be facing all kinds of different quadratic equations. And what you're going to want to do is figure out what's the easiest way to solve this thing. Am I going to factor it? Am I going to use the square root property? I'm going to use the quadratic formula. Remember, why would you use a quadratic formula? It works every time, but mostly because you have to. It's like, okay, I can't do the easy things. Like in this first one, I'd move the 16 to the other side and then use what method? Well, the square is already completed. It'd be the square root property. Square root property would be what I would do on that one. Just move the 16 to the other side. How about the next one? Are we going to factor this one? Good luck. Yeah, I don't think this one's going to factor. So this one, can I use the square root property on this one? Not really. Square root properties, if you have something nice like, x squared equals 25, take plus or minus the square root. I mean, this one I can move the 16 over and I get something that looks like the square root property. But your choices here are going to be the square root property, quadratic formula, or factoring. Completing the square. I'm going to put that in the category with Narn. Complete the square. Yep, and rip. We're not going to use that to solve our quadratic equations. We will use the process, though, to do things later. So you do need to know the process, but as far as completing the square to solve a quadratic equation, no fun. All right, so we're stuck using the quadratic formula on this one. How about this one? How would you work on this one? Factor it. Absolutely. This one's kind of a hybrid. This one will actually factor, but you know what? It's tough to factor these things for a lot of people. So if you wanted to say quadratic formula on that one, that's fine. If you could factor it, that's fine too. How about this last one? What would you do on that one?
That's primes. Isn't it? No. I don't know what I'm thinking about.
Well, see, right here I've got that middle term. But if I don't have that middle term, then I get negative 343. Divide by 7, I get negative 49. Now what would you use? Square root property. So square root property. So just a little bit of food for thought. Okay. So Beanie, no, this one doesn't factor because it's, unless you're going to use quadratic. Beanie Beanie Beachy. Have a great weekend. See ya.